You are now motivated to see an abstract set like that of my lab. Right? Let us define this formally. A set S with an operation star is called a group if it satisfies the following four properties. The first property is for every element x and y in S, x star y should also belong to S. Don't you think it's the same as what I said in the first property of my lab? Second property is for every x, y, z in S, x star of y star z should be equal to x star y star z. As you would have observed, the star here means mix the chemicals x and y, or add two numbers, or multiply two numbers. It could be anything, you see, anything absolutely. Third property is there exists an element E in S such that for every element x in S, x star E is same as x. We also actually write E star x is also x. X star E and E star x is also x. Okay, this may not be true. When you multiply A with B, it may not always be equal to multiplying B with A. You see, when you take matrices, you know this. Right? When you multiply A and B, you might get something. When you multiply B and A, you may get something else. In fact, sometimes A into B of two matrices A and B is possible. B into A may not even be possible. Think about it. There are many such examples. Okay. Fourth property. What was it? Let us try to translate it. For every chemical, there is another chemical X dash, so that X when mixed with X dash gives me the universal chemical E, right? So that translated looks something like this. For every X in S, there exists an X dash in S such that X star X dash is my E from the previous property. If S is such that, with the star operation, if S satisfies these four properties, 1, 2, 3 and 4, what are they? Closure, associative, identity and inverse, then S is called a GROUP, a mathematical group. Okay, I prefix the word mathematical just to make you realize that it's not the same group from the English dictionary. Okay, this is called a group in mathematics. Okay, let us see some nice examples, some obvious examples and not so obvious examples.